Good morning, Algebra 1. Welcome back to our third week of remote learning. Today we're going to start on Chapter 8. It's a little bit of a new topic, but we're going to start with a little bit of an old topic. So first, let's check what our question for today is. What are we going to learn today? Our focus question today is, how is the additive inverse used to subtract polynomial expressions? So we can see from this, we're going to be learning about polynomials and subtracting them. We're also going to add them, and we're going to use this thing called the additive inverse to do that. Now, you might already know what that is. You might not just know the name. So we'll talk about that a little bit later. First, let's see if we can review a little bit about monomials and learn a little bit of new information about them. Okay? So we've talked about the word monomial last week and the week before. It's got mono in the name, and mono means one. So these are math terms that have one term. Now, one term can mean it has, it could be 4x. That's all one term together. You can have multiply, you can have divide, you can have them stuck together, which is multiply. So this is a monomial. Today we're going to talk about what is the degree of this monomial. So I'm going to unwind my cord. Okay, now we're going to check. So if we remember, when we talked about exponents, we call those, 4x to the third degree, the third power. But this one, what's the degree here? What power does it have? If there's no power on the variable, on the letter, we know it's that invisible 1, right? So the degree is going to be 1. Nice. Okay, what if we have something a little more complicated than that? What if we have, so this is still a monomial, 12x to the third, y to the ninth, z to the fourth, and q squared. So that's a lot of stuff, but it is still one math term because it's all multiplication. It's a little slanted too. Wow. So right here it's 12 times x cubed times y to the ninth times z to the fourth times the q squared. They're all multiplying together. So it's one term. How could we figure out the degree? Well, we see a degree 3, a degree 9, degree 4, degree 2. We just need to pick the highest degree. And the highest degree here is the 9. So the degree of the whole thing is 9. Okay? Let's look at some things that disqualify a monomial. These are not monomials on this side. Okay? I'm going to write them in red because they are not monomials. Well, let me fix that. Okay, these are not monomials on this side. Let's start with square root of x. Okay, square roots, they are not monomials because we can't have what's called a fractional exponent. And we didn't talk about this yet, but square root of x, that's the same as x to the 1/2 power. We can't have fractions in an exponent if we want to call it a monomial. So this is not a monomial. So if you see any square roots, it's not a monomial, it's not a polynomial. This turns it off. Okay, here's another thing we can't have. We can't have 1 over, 3x to the third. Now, if I just said y, just 3x to the third, that's a monomial. So why is this not a monomial? What's the problem? Well, the problem is that we do not have x, we can't have variables on the bottom of a fraction and call it a monomial. So this is not a monomial because of this x down here. Bad. Yeah, it's not bad. The problem is sometimes that could be 0, and then that breaks the fraction. You cannot divide by 0. It messes with all sorts of math. Okay, one more example I have. It's almost the same as this. What if I have x to the negative 6? Okay, that looks okay, right? It's not a fraction. It's not on the bottom. Or is it? So remember, a negative exponent means that we need to move the whole thing to the other side of a fraction and make it positive. So I move it to the bottom of a fraction and make the exponent positive. Uh-oh, now I have my variable on the bottom of a fraction, which means it is not a monomial. Okay? So if you see, this does not always mean that anytime you see a negative exponent, that does not always mean it's not a monomial. Sometimes, like this, what if I start with what? No, not red. Let's use blue, because this is actually a surprise. It really works as a monomial. So what if I have 1 over x to the negative 4? Well, you say, uh-oh, I know that's not, because it's got a negative 4 exponent. But we have to check what that really means. So remember, a negative exponent, we have to move it to the other side. So it's going to go up top. The exponent's going to be positive now. And now, that's okay, because we have our exponent on top, our x on top of a fraction, in the numerator, not the denominator, and we're okay here. Okay, so these are just some examples. You really want to look out for square roots and exponents on the bottom, and you always have to check if you have a negative exponent to see whether it breaks. Okay. That's a little bit of information about them. Oh, well, let's say, what's the degree for this one? X to the 4th. It was negative 4, but when we correct it, when we simplify it, it's x to the 4th. So the power for this one was a 4. Okay, let's move on to polynomials. Okay, so what is a polynomial? Well, a polynomial is just a bunch of monomials added together. Oh, dropped my calculator. So we know that 3x to the 4th, that's a monomial. Okay, now let's add it to 4y squared. That's a monomial. So two monomials added together, that's a polynomial. Okay, we could keep going. Let's say minus x. This x has a 1 exponent, remember, it's invisible. But x by itself, that's a monomial. So we're still good. Okay. And then we could also just say plus 2. That's a monomial. So we have 4 monomials adding together. That's a good polynomial. I'm just going to see. We can also check the degree of a polynomial. So what's the degree here? Well, what's the highest exponent we have over there? Wow, I cannot spell degree. How did I do that? Okay. Absent-minded. Degree. Okay. So what's the degree? Well, in this one we have a 4, we have a 2, the 1, and this is actually a degree 0. So the highest we have is that 4, degree 4. Okay, let's do a little bit of a tricky one, and we're done talking about polynomials. We're going to go add and subtract them. It's a little bit harder. We have maybe 5x squared y to the third. So this is a polynomial. They're all multiplying together. Plus 2xy. Okay. So that's a polynomial. Monomial plus monomial. What is the degree here? Well, what's the degree of this monomial? It's 2 and a 3. So total, this one has 5. This one has the invisible 1 and the invisible 1. So this has 2 for its exponent. There's degree total. So the highest one is that 5 in the first term. Okay, that's just a little bit about polynomials. All right, I'm going to go do some of my own practice problems and leave you the practice problems in the packet. So the real trick to polynomials, we're going to add them first. This is a little bit easier. The real trick to polynomials is that we are just going to combine like terms. Okay, I'm actually going to write that up there if I can. The secret to adding and subtracting is that we need to combine like terms. So they have to have the same variable with the same exponent, then they can be combined. So let's look at my first example. This is not from the packet. There's not very many problems in the packet, so I made my own. So you can work on the ones in the packet. We have 3x to the third minus 6y plus 4. Okay, that's one polynomial. Then we're going to add it to another polynomial, which is x cubed plus 13y minus 3. Okay, so we have our two polynomials. And what I want to do first is I'm going to go look for the like terms. So I'm going to look at my first polynomial and say, oh, I'm looking at the variables and the exponents. This one has an x cubed. Okay, I want to look at my whole problem. Do I have another thing that says x cubed? Yes. So underline that too. And we're going to combine those. So we're going to add those. We're going to do 3x cubed plus x cubed. Okay, so that's our first piece. I don't see any more x cubes that I could combine. All right, we're going to keep going down the line. We've got negative 6y. So this is a y. Do we have a plain old y in the other thing, the other polynomial? Yes, we have plain old y. So we're going to add those together. So we've got negative 6y, plus 13y. Okay. Oh, and this is between these. We're going to start with plus and see if we stay with plus. But plus and plus. Okay, let's keep looking. Okay, now my last piece of the first polynomial is this 4. Do we have, so this has no variable. Do we have a number with no variable on that side? We do. We have this negative 3. Okay, let's combine them. They are like terms. We have 4 plus -3. Done. Okay, let's do our little math problems now. First, we have 3x cubed plus 1 more x cubed. How many x cubes do we have now? We have 4x cubes. Remember, when you add variables with exponents, nothing happens to the exponent. It stays the same. You're just adding the coefficients. Remember, when we multiply them, like we did last week, that's when the exponent can change. Okay? Let's do our problem in here first, then we'll see if it's still plus. -6y plus 13y. Okay, I can use a calculator here, or I can use my brain. And I'm going to say -6 plus 13 is a positive 7y. So this was positive, so we're going to keep the plus. Okay. Then our plain numbers. 4 plus a -3. So remember, plus and a minus next to each other, that just means minus. So 4 minus 3 is 1. And that's a positive 1, so my plus just comes down. Okay. And actually, I'm just going to move this guy over. Plus 1. And there's my final answer. When I add those two polynomials together, I get this new polynomial. Okay. So when you're adding polynomials, you're just combining the like terms. Oh, x cubed. Oh, x cubed. I have 3 of them here and 1 of them here. That means together I have 4 of them. Okay. Sometimes you won't have everything match up. So let's do one more example of this. Yep, I got time. Okay. One more example of adding polynomials. Okay. What if I've got 5x squared plus y minus 1. And I want to add it to a -x plus 4y minus 1. Okay, well, let's start off with our first term. We have 5x squared. Okay, so this one has an x squared. Do we have x squared anywhere else? No, we don't. So we're going to add 5x squared plus nothing. So it's just going to stay 5x squared. Okay. Now let's check the next term. Different color. We have positive y. Do we have another y anywhere? Yeah. We have 4 of them over here. So they have the same variable, and both of those y's are just plain y with one exponent, nothing fancy. So we can combine them. So it's going to be y plus 4y. Okay? And remember, we start with a plus between them just in case. All right, another color. -1. -1. Do we have another plain old number? We do. We got another -1. Okay, let's add them up. We got -1 plus -1. Done. Okay, put our plus sign between them just for now. And one more color. Go with dark blue. All right. Then I'm looking. Finished. We're missing something to do with this term. We have a -x. Is there another x anywhere? Well, there's this x squared, but x squared is not a like term with x. That one's squared. This one's just x. They are not like. So we will just say minus x. That was a really wacky x. Let's try it again. Minus x. Okay? All right, let's try simplifying it out a little bit. So we've got 5x squared. Then we got y plus 4y. How many y together? Oh, that's 5 y's. And it was plus. Okay. Now we've got -1 plus -1. This one's not too hard, but make sure you check it in case your calculator is better. -1 plus -1 is -2. Okay? Because it's negative, we don't bring the plus down. So it's going to be 5y minus 2. That's good. And we just have minus x. Okay, so this is the answer, but we want to put things in alphabetical order. So first we check, what's our highest exponent? I'm going to put that in front. Okay, so the one that has the highest exponent. Now, what's the next highest exponent? Well, this y has a 1, and this x has a 1. So we put them in alphabetical order. So minus x plus 5y minus 2. So there's the final answer. Okay, so sometimes you don't always have like terms that can combine with everything. So you combine what you can, and if something doesn't have anything to combine with, it's just going to come down as itself. It won't change. Okay. Let's check subtracting polynomials. Okay, same idea. We're going to combine like terms. We just have one extra step beforehand. And that's called the additive inverse. Remember, we said that in our question at the beginning. So, for an example, what if I want to do the same thing we started with? What if the first of the adding problems, but we're going to subtract them this time. 3x to the third minus 6y plus 4 minus, so that's the difference this time. Now we're subtracting the two polynomials. That's important. Minus, then the other one was x cubed plus 13y minus 3. Okay, so here's what we do. This is called the additive inverse. So we're going to make our additive inverse, and I'm going to write down the name. Whoa, not like that. Okay, this is the, oh, I'm losing tracking. That's why. Here we go. Okay, this is the additive inverse. So what we do when we see this, put the eraser down. When we see this minus here, when we're subtracting polynomials, we want to take this minus and distribute it. So it's going to make all of these opposite. So we're going to take the opposites. So instead of x cubed, the opposite of x cubed is negative x cubed. Okay? 13y, positive 13y, the opposite is negative 13y. Whoa, that's a tricky 3. Negative 13y. And then the opposite of negative 3 is positive 3. Okay, that's the additive inverse. Maybe I'll just write that 13 again. A little neater. 13y. Okay. Good. A little bit better. Okay. When we do the additive inverse, so now we can just bring down the first polynomial, 3x cubed minus 6y plus 4. And now we're ready to combine like terms. Just like it's an adding problem. Now we just pretend we're adding. So 3x cubed, negative x cubed. Let's write it down. 3x cubed, negative x cubed. Okay. Negative 6y, negative 13y. Negative 6y, negative 13y. Okay. And plus 4 plus 3. So we've got a 4 plus 3. Okay. And in the last example, we just assume we start off thinking it's plus. If we get a minus instead, we'll change it. Okay. So 3x cubed minus an x cubed. How many are left? 3 minus 1. So we only have 2x cubes left. Okay. Let's check the blue. Negative 6y minus 13y. Check this answer on your calculator in case you get it wrong, because negatives are tricky. But it's going to be negative 19y. Okay, and because we got negative here, we don't bring our plus down. So it's just 2x cubed minus 19y. All right, and then the last piece, 4 plus 3 is 7. It was a positive 7, so it's plus. And there we go. There's our finished answer. Okay? So subtracting polynomials, all you need to do is make the opposite of the second polynomial, right? We did opposite to get negative, opposite to get negative, opposite to get positive. Then you're just adding them again by combining like terms. So it's the same as adding, with one step in front where we take the additive inverse. Okay, I can do one more example. Remember, these examples today are not in the packet, but the packet is a little bit short today, so you don't have to worry too much. Okay, we're going to subtract the other example I used. 5x squared plus y minus 1. Now we're subtracting. Minus. Then this one was negative x plus 4y minus 1. Okay. First, we need to do our additive inverse. I don't know why I erased all that. Additive inverse. So, then subtracting, because we're subtracting them, let's make this one opposite. So, opposite of negative x, well, that's going to be positive x. Okay. Opposite of 4y, positive 4y, is negative 4y. And opposite of negative 1 is positive 1. Okay. Our first term did not change. We have 5x squared. One's a bad squared. X squared plus y minus 1. Okay. So the first term did not change. The second term became opposite, or the inverse, right? Inverse means opposite, mostly. Now we're going to combine. Okay. Start with the first term, 5x squared. Anywhere else have x squared? Nope. So we'll just write it down here. It's 5x squared. But remember, this time it's minus 0 because it's in the front and there's not one over here. So it's minus 0. That's going to be easy. Okay. Next term, y. Is there a term with just a y? Yep. Negative 4y. So let's put it down here. We've got y minus 4y. Okay. Put our pretend plus between, just in case. Okay. Next one, we have plain old number. Do we have another plain old number? We do. This one's a positive 1 over here. Okay. So we have negative 1 plus 1. Well, I think I already know what that is. Okay. Remember, there's a plus here until we know otherwise. And then last one, dark blue. We have this plain x over here. It doesn't have a partner either. So there's not any x over here. There's x squared, but not an x. So in here, there's 0 of them. And in here, there's plus x. Okay. It's important if you have no like term in the first polynomial, put a 0. Just so that we can add or subtract the term from the second polynomial. Just like we did here, right? We had a 5x squared only in the first one, minus 0 of them in the second one. Okay, so we put the 0 in there when we don't have the other like term. Okay. Plus, just in case, now we just check each one. Okay, 5x squared minus 0. Well, if you take away 0, nothing changes. 5x squared. Okay. Y minus 4y. So we've got 1y minus 4y. So 1 minus 4, that's negative 3y. Because it's negative, we don't bring this plus. Okay. Over here, negative 1 plus 1. Well, if I start here, go negative 1 plus 1, I'm back at 0. So this is 0. I'm going to cross that out. I'm not going to put 0 here. I don't need it. And over here, 0 plus x. Well, if I start at nothing and now I have an x, well, that means I just have an x and the plus sign. Okay, so that's good. Let's just put it in alphabetical order from highest exponent first. So here's our highest exponent, 5x squared. But next one in alphabet order is x. So plus x minus 3y. Same number, just the proper way to write it. Okay? So that's all we're doing today in this lesson, is adding and subtracting polynomials. And the secret to that is to combine like terms. When it's a subtraction problem, you do the additive inverse first. You make the second one opposite, all these opposites. Then you just combine like terms. Okay? So adding and subtracting are the same. Subtracting just has this one more step you need to do to make your opposites. Okay? Remember, we have a class meeting Tuesday morning at 11:15. And every day we are here to answer your questions at 1 p.m. If you need other times, send me a message during the week and we can work something out. Okay? See you next time.